Hello, and welcome to my Pre-Algebra review series. This video covers Chapter 2, Section 1, titled Properties of Numbers. By the end of this section, you'll have reviewed the procedures for identifying and using the properties of addition and multiplication. Additionally, you will explore aspects of using mental math with both addition and multiplication. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and it certainly will help this channel to be seen by more students. If you would like me to cover any of the topics in greater detail, please leave a comment in the comment section below. I read them and do my best to answer each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. Let's get going. Okay, before we get into it, I'd like to talk about a couple definitions. Additive identity. When you add a number and zero, the sum equals the original number. The additive identity is zero. Multiplicative identity. When you multiply a number and 1, the product equals the original number. The multiplicative identity is 1. Okay, Objective 1A, identifying properties. The sum of 6 and 4 is the same as the sum of 4 and 6. Similarly, the product of 9 times 5 is the same as the product of 5 times 9. And these suggest the following properties. So, a key concept here, the commutative property of addition and multiplication. Changing the order of the values you are adding or multiplying does not change the product. So looking at from an arithmetic point of view, 6 plus 4 is equal to 4 plus 6. They both equal 10. 9 times 5 is equal to 5 times 9. They both equal 45. If you do it from the algebraic point of view, A plus B is the same as B plus A, and A times B is the same as B times A. Doesn't matter what order you multiply or add these in. Okay. You can also change the grouping, the way the numbers are grouped, the grouping of the values before you add them or multiply them. Again, for instance, the associative property. This is how we associate the items together. The associative property of addition or multiplication. Changing the grouping of the values you are adding or multiplying does not change the product or the sum. Arithmetically, 2 plus 7 plus 3 is exactly the same as 2 plus 7 plus 3. So it doesn't matter how you group them. They both come out to 2 plus 7 is 9 plus 3 is 12. They both come out to 12. And or 9 times 4 times 5 is exactly the same as 9 times the quantity 4 times 5. They both equal 9 times 4 is 36 times 5 is 180, or 9 times 20 is 180. No matter how you look at it, they both equal the same number. Algebraically, A plus B is equal to plus C is equal to A plus B plus C, and or AB times C is the same as A times BC. Okay, Objective 1B, identifying properties. From the definitions above, you'll remember that when you add a number and 0, the sum equals the original number. That's called the additive identity, is 0. When you multiply a number and 1, the product equals the original number. That's the multiplicative identity, and it is 1. So the key concept here is the identity properties of addition and multiplication. The sum of any number and 0 is the original number, and the product of any number and 1 is the original number. That's why they're calling it identity. It comes back at the same number, same value. So from arithmetic viewpoint, 12 plus 0 equals 12, but multiplying now, 12 times 1 equals 12, so they both equal 12. Algebraically, A plus 0 is equal to A, and A times 1 is equal to A. Okay, example 1. It's a real-world problem we're going to solve here. So Carlos rented a set of golf clubs for $7 and a golf cart for $12. Additionally, he paid a green fee of $23. Find his final cost, his total cost. Well, you can use the associative property of addition to find the total cost in two different ways. We've talked about it before. We'll look at it in real life here. So we have as we see from here, $7. We have the $7 is his club rental. $12 was the cart rental. That's the cart rental, $12. And $23 is the fee, the greens fee. So you can add, as we're going to show here, you can add the 7 plus the 12, and then add the 23. 7 plus 12 is 19, plus 23 is 42. Or you can say 7 plus the quantity, 12 plus 23. 12 and 23 is 35, and you have 7 plus 35 is 42. So no matter how you do it, the same price. Clubs, green fee, and cart, $42. Okay, here's a short problem to check our understanding. It says you spend $6 for dinner, $8 for a movie, and $4 for popcorn. Find your total cost. Explain which property or properties are used as you're doing this. Well, so we wrote them down. We have the $6 for the dinner cost, $8 for the movie cost, 6 and 8, and the $4 for the popcorn. So what we've chosen to do here is we've added the 6 plus 8 first. We get the 14. 6 plus 8 is 14 right here. And then we add the 4 later. Well, what did we use in this grouping? The 6 plus the 8, the grouping here, the quantity. It's the associative property of addition. We can associate 6 and 8 and then add 4, or 6 plus the 8 plus the 4. It doesn't matter how you associate them and group them. You can associate them any way you want and add them. And then the final thing is once we've added the 6 and the 8 to get 14, we add the 4 to it, still part of the the associative property. And we're going to get 14 plus 4 is equal to, you got it, 18. Okay, for example number 2, they just want us to identify the properties. A little exercise, no real math involved, just trying to remember what these are. Name each property shown. So in A, here's A first, right here. It says we have 5 times 7 is equal to 7 times 5. So what is going on here is we're moving the 7 and the 5 switch places. Here the 5 move to where the 7 is, and vice versa. Here the 7, now you see that the 7 was at the end, now it's at the beginning. So it's moving around, it's commuting. It's like taking a ride in a bus. It's moving back and forth. It's the commutative property of multiplication. The next is C times 1 is equal to C. So what is it when we had a number times 1? It's the identity property. This is a property of multiplication. And then the 7 plus A is the same as A plus 7. It looks the same as the multiplication. It's the commutative property, the ability to move order. Flip this one over here, move that one over there. It's the same difference. Okay, as long as you're not flipping it to the other side of the equal sign. It has to be on the same side of the equal sign. And then lastly, D, 5 times the quantity x times y is equal to the quantity 5x times y. Well, what are they doing? We're grouping these differently, right? We're associating these numbers in a different order. And that takes us back to the associative property, the way we're associating them. Okay? Okay, here for example 2, and check your understanding, we just have more of the same thing. It's nothing major. They showed you something going on and they want you to name it. Well, I've already taken the liberty to do it for you because we're not doing the problems online. So, because we're just talking about it anyways. So in this case, 3 plus 6 is equal to 6 plus 3. What's happened? The 6 and the 3 changed places, right? And when values change places like this, it's called commuting. You commute, the commutative property of addition. For B, 8 equals 1 times 8. Doesn't matter what side of the equal sign this multiplication is going on. It's still a number times 1. Here's the number times 1. And any multiplication times 1 is talking about identity. Its addition is plus 0, returns the same value. And in multiplication, times 1 returns the same value. Identity property. And C, 3z times m is the same as 3 times zm. And what is that? What did we do? What is this? We grouped these. It's how did we associate these? We associated them this way. And in this one, it's the z and the m we associated together. So, because you can only multiply in your head. Let's say it's 4, 5, and 9. You can only multiply two numbers at one time. So you have to associate them somehow in your head. So this is the way you do it. This is the associative property of multiplication. So for objective 2, we're going to be using these properties, and we're going to start thinking about mental math. And that's what we talked about that before. You can use properties and mental math to help you find sums. So we're going to be able to break things apart in our head and say, well, we can do this times that. That's an easy number, and this times some other numbers. You add the two easy numbers together. That's basically what we're talking about here. So we'll see how that goes. Okay, example 3, using mental math with addition. Use mental math to simplify 81 plus 6 plus 9. So what they're implying here is we're going to look at these numbers, and what would be we're going to use the commutative property or the associative property, whatever it is that we've already just learned. How would you move these numbers around to make them easy to add real quickly? Is it easier to say 81 plus 6, and then you go 87, and 87 plus 9 is whatever, okay? Or is there a way of adding them differently, quickly, and getting an easy answer? So there, we write down the problem here. We've already got the 81 plus 6 plus 9. So the first thing they say, using the commutative property, we're going to take and we're going to move these numbers around. So we move the 6 and the 81. We flip, they were like this, right? 6 and 81, we moved them this way. So now we got the 6 first and the 81 second. And then we're adding the 9. That's using the commutative property because we can switch them around. Then we'll say, well, let's associate them. Right now they're associated with the 81 and the 6 are associated together. So now they say, well, why don't we associate the 81 and the 9 together? Because guess what? 81 plus 9 is easy, right? It's 90. Here, 81 plus 9 is 90. And then you got this lone little 6 over here. So you add 6 to 90, right? We switch the parentheses, add them up quickly. 81 and 9 is 90 plus 6, 96. Made it simple. That's the mental math part. How can I flip that around in my head to come up with an easier answer than trying to put the tougher numbers together and work it out? Okay, now example 3 under check your understanding. They want us to do some of that mental math, moving numbers around and changing the order and finding easy ways to do this addition or whatever it is. It is all addition, as a matter of fact. So use mental math to simplify each expression. So let's take the first one here. So what do we have? We have a 6 and a 7. Okay, we could add those together and get 13 plus 14. And we can come up with an answer. But would it be easier if we moved? Let's say we took and we wrote the 7 and we switched the 7 and the 6 around. And we left the 14 right here. So now that we've done that, and we take the 6 and the 14, and we're going to do them first. But what happens when you get 7 plus 6 plus 14? What is 6 plus 14? Yeah, it's easy. It's 20. So there you have it, 20. So what is 7 plus 20? 27. So they're showing you could quickly move the 6 over to the 14 and get a 20 out of it. Let's go to B here. Well, we have the 0, a 2, a minus 7. We have an 8. Well, 7 and 8 together, is that what the 2 we can forget about? But, oh, we could do this. We can say 8 and get the 0 out of there, plus 2 plus negative 7. And when we do that, these two we can group together, and guess what? We get a 10. And then plus a negative 7, well, that's just minus 7, so that equals 3. Okay, how about this one, number C down here? So what do we have? We have a 5, a 12, an 18, and a 5. Well, right off the bat, oh, look at that. 5 plus 5, we got those two together. And that leaves us with 12 plus 18. Oops. Okay, I've got to get that 1 squeezed in there. 12 plus 18. Well, these two we can add together. Duh. 10. Okay. Plus what? Well, 12 and 8 is how much? 12 and 8 is 20, but it's 18, so that makes it 30. Or you could look at it as 1 plus 1 is 2, plus another 10, it makes it 3, so it's 30. Now, how you do it? You end up with 30. 10 plus 30 equals 40. Okay? This next one. D. 19 plus a negative 30 plus 21. Well, I think that if we look at this, we see that the 9 goes pretty good with the 1 to add to make a 10. And this is 2 10s and 1 10, so you've got 3 10s. So let's put them together. Let's say 19 plus 21 plus a negative 30. Okay? So the 19, if we group them together, like I said, the 9 and the 1 create a 10, which gives you a 0. And you're going to take the 1 from the 9 and add them to these, so you got 3, 4. So there's 40. Plus a negative 30. Well, that's just 40 minus 30. 40 minus 30 is equal to what? 10. There's our answers. Okay, so example 4 is a real-world problem. And they want us to solve this school supplies. We're purchasing school supplies. So suppose you buy the school supplies at the right. That's these guys over here. Okay? Use mental math to find the cost of the supplies. So mental math. We wrote them down. $1.65, 85 cents, and 35 cents. So first thing we want to do is, what can we add? What can we put together that makes it kind of simple? Well, they want us to move the 85 over to here and the 65 to here, and you'll see why in a second. So now we got 85 plus the $1.65 and the 35, because the 65 and the 35 fit nicely together, because 65 and 35 is cents makes a dollar. So now you have $1 plus one more dollar. So $1.65 plus 35 is $2. Okay? And then when you finally add your 85 cents in that we had in the beginning that we put off to the side here, it's 85 cents plus $2 is equal to $2.85. And how did we do this? We took when we moved the numbers around to get these two together in our head, we could see them together in our head, we used the commutative property of addition. We took these additives here and we swapped them, swapped this one from here over to here, and this one from here out to here. And then we used the associative property to group these together and add them, come up with the $2, and we made it $2.85. So for example 4, we have another check your understanding. So we're going to do it on our own here. So what are we going to do? It says, use the supermarket receipt, that's right there, and mental math to find the cost of the groceries. So we had a gallon of milk for $2.30 right here. A gallon of milk, $2.30. We had bread for $1.80, and we had apples for $2.20. So writing the numbers down, $2.30, which is the milk, $1.80 is the bread, and finally $2.20 is the apples. So now what can we do to these numbers to make it easy as we're looking at them to do it in our head? Well, what goes together comfortably? Is there anything with the 30 go together comfortably? No. I guess 30 and 20 is 50. But if you take the 80 and the 20 cents, that's $1. So now you have $1.80 plus $2.20. So you have 1 plus 2 makes 3, plus the dollar that these two together add up to in your head makes another $1. So that's 4. So now we're at $4 here. And then what do we have over here? We have $2.30. And when we add these together now, we get, so $4 plus $2.30 is $6.30. Okay? Example 5, using mental math with multiplication. So instead that last one was addition, we're going to do a little game with the multiplication. Now let's see what it's telling us. So it says, use mental math to simplify 4 times 9 times 5. Okay? And they have it grouped for you already, 4 times 9. The quantity, 4 times 9 times 5. So they show us, well, are we going to regroup it? Well, let's see. We start off with right here with the 4 times 9 times 5. That's this number here. And using the commutative property, we're going to switch some things around. And what are we going to switch? Well, we switched the 9 went over to here, and the 4 went over to here. We had the 9 and the 4 switch. Okay? So, and why did we do that? Well, then now the 4 is next to the 5. And it's easier to picture it in your mind now. You say, oh, I got the 9 over here all by itself. I'm going to move the parentheses, the associative property. How am I going to associate the numbers together? Before, the 9 and the 4 were associated together, giving it 36 times 5, which is maybe not a hard number to handle, but a little tougher than in this case. If you had 9 times 4 times 5, 4 times 5 is 20. 20 times 9 is 180. Because 2 times 9 is 18, plus times with the 0. So they're showing you how we moved it around and quickly got the 20. So, which is easier than saying 36 times 5, which is also 180. In that case, I would have said 5 times 30 is 150, plus 5 times 6 is 30. 150 plus 30 is 180. You get the same answer, but maybe not as quickly. And in your head, if you're not looking at the paper, it might be a little more difficult. Example 5, check your understanding. Use mental math to simplify each expression. We just did. Okay, so let's start with A. What is it? We have a 25 times 3 times 4. Well, is there anything we can do to make this? We could do 25 times 12. Okay, we could just do it directly. Or we could say, well, maybe we could shift the numbers around a little bit. What if we said 25, we moved the 3 and the 4. If we switched the positions of the 3 and the 4, we'd have 25 times 4 times 3. Okay? Well, now, if we regroup it, if we have 25 grouped, that's times the 4, grouped times the 3, 5 times 4 is 100, times 3 is equal to 300. So that little grouping was kind of convenient. Made it quick, you could see it. You can look at, 25 times 4 is 100, times 3 is 300. Okay. How about B over here? 3 times 1 times minus 5 times 8. Well, let's look at that. What do we have? We have 3 times 8 is 24. We have 5 times 3 is 15. The 1 is kind of meaningless. It's not going to do anything for us. But I guess we can just look at this and say this does nothing. If we said the 8 times 5 is 40, it'd be minus 40. Okay, minus 40. And then we got rid of the 1, so we're just going to associate these right off the bat. These two we're going to associate together, and you get a minus 40. And minus 40 times 3 is minus 120. Looks complicated, but just deal with the negative sign. It's not going to hurt you. And like the 1 did nothing to we didn't have to even think about it, because you can multiply by 1 all day long. Doesn't affect any answer. Okay. C, 2 times negative 8 times negative 15. So what does that come out to? Well, 2 times 8 is 16. 2 times 15 is 30. Okay. And 30 times 8, well, what is 30 times? That's 3 times 8 is 24. Maybe that's the way to do it. Maybe it's to say, if we took the 8 minus 8 over here times 2 times minus 15. Okay, so here we're going to have 2 times 15 is negative 30. And we have negative 8 times, so it's negative 8 times negative 30. So the negatives cancel. 30 times 8 it's 240, but you get that quickly by saying 8 times 3 is 24, and then you multiply by 10, which is the 0, and the negatives canceled, so 240 is your answer. Over here on D, we have 5 times 9 times 6 times negative 2 times negative 1. Well, what can we do on this one? I have to think about it for a second. 6 times 5 is 30. The negative 1 we don't care about, except that negative 1 and this negative 2 cancel each other. It just becomes 2, because the one negative, the minus signs cancel each other. So now we've got 5 times 9 is 45. times 6 is, I don't know, maybe a little different. What, 9 times 6? 54. Let's see. 9 times 6, or I'm going to say 30. 6 times 5. Put this, maybe I should delete that. Hold on, sorry. We should probably say, oh, get the pencil. There we go. We should say 5 times 6. So we're going to move these two around, the 9 and the 6, times 9 times 2, because these canceled. So 5 times 6, we'll group these, and that's going to be 30. 30 times 9, or we could do 30 times 2 and make 60. 6 times 9 is 54. Not a bad way to go. So we could then move these two around and say times 2 times 9, and 30 times 2 is 60 times 9, and 6 times 9 is 54. 54. And a 0, because you have to multiply this 60 by the 6 by 10 to get 60. And the answer is 540. Think about those a little bit. Stop the slide and look at it and just kind of imagine what we did there, okay?